Okay, returning to this. So my point I've been making, I just started the recording a little bit late, is that we've got sine theta equals cosine theta on the left, slide number 1 there. So we first of all consider what reference angle would suit that, and the answer is when theta hat equals pi on 4, 45 degrees. And then we're just going to consider each of the cases in turn. So we're looking at theta being between 0 and 2 pi, and then we'll look at theta between negative 2 pi and 0. So what I did here so far is I've just noted that what the signs of sine and cos are in each of those 4 quadrants, because we need to make sure that sine and cosine are equal. So they're equal here, they're equal here, they're not equal in the other 2 quadrants. Okay, so we don't have to consider the other 2 quadrants. Okay, that actually, you know what, that actually really should be in general. Doesn't matter about the specifics there. In general, that is the case. Okay, so they're only equal in the 2 blue quadrants there, and they're the only ones I have to worry about. In other words, when looking at the cast diagram, we can infer that, or by saying the y-axis is positive and the x-axis is positive here, the y-axis is negative and the x-axis is negative here. So these are the 2 possibilities. So moving from this, we now can break it down into our 2 separate things. So I'll go between 0 and 2 pi, so the positive spin or the counterclockwise spin. So that'll be something like this. It'll be here for 45 degrees. And then it will be here, 45 degrees in here, but the actual angle will be there. Okay, and that means this one will be here's me using degrees after I just told you not to do that. 180 plus 45, which is equal to 225 degrees. Okay, now I'll just say that again, but in radian language. Gosh, I'm naughty, aren't I? So this one here is pi on 4. In this quadrant, this has to be pi on 4 as well, because that's our reference angle. So this thing must be pi plus another pi on 4. And so in this quadrant, we've got theta is equal to pi on 4, 45 degrees, and 5 pi on 4, 180 plus 45, 225 degrees. Okay, is that okay? Can I move on? Okay, what about the other one? So between negative 2 pi and 0, same quadrants. We're still considering all 4 quadrants. We just need to go backwards. So this quadrant's out, and this quadrant's out. So we simply need to look at 45 degrees here. Remember, oh man, you know what I'm doing wrong, don't you? Remember, it doesn't matter whether it's clockwise or counterclockwise. The reference angle is always between the line and the x-axis, always, always, always. So we're still getting pi on 4 here and here. It's a bit small. Let me zoom up for you. So the pi on 4 is here and here. And so I'll now put in my actual angles, which will be this one, or to that point, or this one to that point. So what's this one? This one here, this little inside track, is going to be all the way to negative pi, but not quite. So it's going to be less than that. Okay, so that's going to be 1 pi on 4 less than that. So that means that theta is going to be negative 3 pi on 4. Is that okay? A quarter pi less. And the outside one, so I'm now looking at this one, it's almost all the way to 2 pi, but not quite. So it's going to be pi on 4 less. So you just got to think, well, what would 2 pi be? That'd be 8 pi on 4. So that's going to be negative 7 pi on 4. Yeah? It actually really is quite easy to work in radians as long as you've got your fundamentals of fractions okay. As long as you can say that 2 pi, yeah, I get that. That's 8 pi on 4, etc. It's not too bad. So I'll just conclude by putting a final statement, i.e. theta can be pi on 4, I'll go in order. So negative 7 pi on 4, that's the smallest. Negative 3 pi on 4, that's the next one. And then we've got pi on 4 and 5 pi on 4. Done. 4 solutions. Is that okay with everyone? Cool. Hopefully you got there. I mean, the thing is, I saw quite a few of you having complete blank looks on your faces to start with. Some of you had sort of like, looks on your faces. No one had obviously, and then looks on your faces. Mathematicians don't have the answers, right? They just have the tools to get them. And that's what you've got. So it's okay to start from a place of, well, I don't know the answer yet, but what tools have I got that'll help me unpack it? And that's what you guys did. Looked at a table of values, or whatever you did, you used your tools. Let me show you the alternative way of solving it. I won't do the full solution because it's only the first bit that's required. Sine theta equals cosine theta. Okay, so if I divide both sides by cosine theta, yeah, you do have to write this though. Assuming cos theta does not equal 0. Then we have sine on cos equaling 1. On your if you originally thought it, then you were right, weren't you? If you have a look at your table of values now, what angle would theta hat be for tan theta hat equals 1? See how it all works in? I love it when maths does that. Tan theta hat is equal to 1. Therefore, theta hat equals pi on 4. And if you have a look at the quadrants, where is tan positive? Oh, guys, look, I'm circling it now. Tan is positive here. And the gradient, remember that tan is the positive gradient. The gradient is positive here. Just the same two areas. Everything in maths interlinks with each other. You don't get a different solution by taking a different approach unless your approach is wrong. So you get the same two spots, and you'd work out the same angles as a result. Okay, because you're looking in the same spot with the same angle. Yeah? Which way is wrong? Neither. Which way is faster? Debatable. Really, it's debatable. This requires a little bit more brain work to start with, but then when you've got a simple tan here, it's really easy to see the 45 degrees and stuff. This approach here requires you to see that you'd have to look on your table of values for the place where sine and cos are the same value. So this requires more thought here. This requires more thought with your calculations, I suppose, firstly. Okay, I'm going to pause the video in a second because I'm going to give you, probably just 10 to 15 max to have a go at the problems that I've got on the board there for you. And then I'm going to introduce you to something a little bit more tricky. Kick it up. Okay, so welcome to the next level. What's different about this one? Yeah, there's a 2x, whoever said that. So that's the difference. And what's its impact? Its impact is how many solutions there will be as a result. Now, this is where having done the sine, cosine, and tan function, it's easy to see what happens here. Effectively, what we do is it changes the period of the function. So because the input to the function, instead of being x, is 2x, it means it slows the function down. So you end up with a longer period, I suppose, before it starts repeating. Okay. Now, Jeremy said there'll be fewer solutions, or I think you said, or something like that. Yeah, and that's basically what happens. Great. But what I'm going to do is I'm going to show you a surefire way of not getting confused over this. It's really easy. Okay, so you don't have to get confused. What we do is we do a quick sub, and we say it doesn't matter what variable you use. Oops, I'll keep that zoomed out. Doesn't matter what variable we use, but I tend to use theta if x is in the problem, or x if theta is in the problem. Just, you could use alpha or something else if you wanted to. So I start off by saying, let theta equal 2x. Then sine of theta is equal to 1/2 for, and what we're going to do is we're going to double that restricted domain. So we've got 0, actually, yeah, I said it around the wrong way, Jeremy. It actually makes more solutions. 0 is less than or equal to theta is less than or equal to 4 pi. So that's 2 times 0 because of the question start. That's what I started with. So I take the starting domain, and there's the new domain, right? The new domain or restricted domain is now between 0 and 4 pi because I've doubled the endpoints. So if it was sine 3x equals 1/2, I would say it's between 0 and 6 pi. I'd triple the endpoints. If it was between negative 2 pi and 2 pi, it would be between negative 4 pi and 4 pi. Okay, all I'm doing is I'm multiplying out the endpoints. Okay, does that make sense so far? Yeah, and the good news is after that, the rest of it is actually just solving it like you've done before, but usually for a bigger or smaller domain. So we know that for sine of theta equals 1/2, what would theta hat be? I've even drawn a little diagram for you, haven't I? Not yet. So just bear with me, right? I don't mind that you're anticipating me, but just bear with me because I'm trying to do it in a structured way. So for the rest of the solution, until the last line, we just deal with theta. Don't worry about 2x, just let's go with theta, all right? So theta hat is equal to pi on 6, yeah? 30 degrees. I drew my little half an equilateral triangle there while you weren't looking so that I could remind myself of the angles. So therefore, what have we got? This quadrant, sine is positive, and this quadrant, sine is positive. So for theta between 0 and 2, you could do this in one diagram, but I'm going to split it into two. For the first rotation, I'm going to have pi on 6 here and pi on 6 here. So my first rotation is going to be here and to here. Is that okay? See, well, I don't know what you think, but I just think splitting it up into those single rotations as much as you can just makes much more sense than trying to do it all in one diagram. And then after 2 pi and up to 4 pi, we're going to have the same situation again. It's going to be here and here again. Sorry about my squishy diagram, but the angle is going to be, I'll do it inside first. All the way around, and then, oh my gosh, all the way around. Snail shell time. Is that okay? So there's my diagrams. Now I just need to translate those into angles, which I'll do on slide 8. So therefore, if we look at the first one there, that's pretty easy. Therefore, theta equals pi on 6, and it also equals, let me see now, that's slightly less than pi, right? It's pi on 6 less than pi. So it's going to be 5/6 of pi, 5 pi on 6. So there's my first axis done. The next one is just going to be another 2 pi on, isn't it? That's not too hard to work out. So it's 2 pi plus pi on 6. Well, 2 pi would be 12 pi on 6. So that's going to be 13 pi on 6. And then the next one is going to be 2 pi, 12 pi on 6 plus another 5 pi on 6. So it's going to be 17 pi on 6. Is that okay? Give you a moment to copy that down and digest that, because the next step is the new bit. Everything we've done now is really just what we've always been doing, working out a whole range of angles. Yeah, so I'm not done yet. I'm just making sure you're right so far. Yeah. Haven't finished. Just making sure you're okay that theta would be those 4 angles. That's all I'm asking you to ask questions about. Yeah, I'll make sure I've got it right too. So I'll say it slightly differently as well. So for the 17 pi on 6, that would be all the way around to here, but back a pi on 6. Well, that's pi, 2 pi, wouldn't it? 3 pi. What's 3 pi as something on 6? That'd be 18 pi on 6. Back pi on 6 makes it 17 pi on 6. Does that make more sense? Yeah, cool. All right, no more questions. So this is the trick, right? Theta was set up in the first place as equaling 2x, right? There it is there. We let theta equal 2x. We don't have to solve for theta, we need to solve for x. So the next step, really nicely, is to simply say which is equal to 2x. All of those values is equal to 2x. But we're not interested in 2x, we're interested in x. So i.e. x is equal to, and I'll just say this without, it'll be on the video if you need to go back onto it, but I'm just going to divide everything by 2. And by dividing everything by 2, I'm just going to go from a fraction over 6 to a fraction over 12. So it'll be pi on 12, 5 pi on 12, 13 pi on 12, 17 pi on 12. Sorry? You needed the exact values here. Yeah, but we didn't have one for 15. No. No. Okay. So that's it. You might notice that this domain stretches from 0 to 4 pi. This domain, once I've divided by 2, look at those values. They go from 0 up to, so remembering that 2 pi would be 24 pi on 12, it's still underneath 2 pi. So following this process does return, once we've done this last step here, it returns the actual solutions back to the restricted domain because we're dividing it, we divide by the 2. It's so good. It is so straightforward. It's a nice, simple process, and it requires less double thinking and more just following through a logical process. What do you reckon? Want to try one? Is it time to stop? Okay, so I'm going to make you try ones because I'm going to give them to you for homework for Tuesday. So your homework is to complete the other ones, and I'm going to give you another textbook reference with a bunch of other questions to try. Yes, it will all be. I'm not going to verbalize it now. So there'll be some where you'll be required to expand the domain because it'll be like cos of 3x, and others will be a restriction of the domain, like sine of half x, in which case you'd have to divide both sides. We'll leave it there. Have a good weekend, everyone.